Now the sine rule is a trigonometric rule that we can use to work out missing side and missing angle. So the notation, if we've got triangle ABC, for sides of triangle ABC is that the capital letters marking our angles are opposite the lowercase letters marking our sides. So side BC is known as lowercase a, side AC is known as lowercase b, and the side opposite angle C is known as lowercase c, so AB equals lowercase c. Now in triangle ABC, the sine rule states that the ratio of the side to the sine of the angle is equal for all three angles and sides. So A over sine A equals B over sine B equals C over sine C. The important thing to remember is that to answer a question, we don't need to use the formula as it's written. We only need to use the first two bits. So in other words, A over sine A equals B over sine B. So you're looking at two ratios. You don't need to look at all three. Now in this video, we're going to look at using the sine rule to work out a missing side. So in this example, we want to find the length x in the triangles shown in the diagram. Now we can see that x is opposite the angle of 35 degrees. And so we can form a ratio of that side over the sine of that angle. And then we can also see that the 9 centimeters is opposite the angle of 80 degrees. So we know that we can use our sine rule. So we're going to write A over the sine of angle A equals B over the sine of angle B. Now if we go back to our diagram, A will be x and the angle A will be 35 and B will be 9 and the angle B will be 80, and we can substitute those values in. So we get x over the sine of 35 degrees equals 9 over the sine of 80 degrees. Now we want to isolate that x in order to determine its length, so we're going to multiply both sides by the sine of 35 degrees, as if we were solving an equation, and that's going to leave us with x equals 9 multiplied by sine of 35 all over the sine of 80 degrees. And if we put that into our calculators, we're going to end up with a value of x of 5.241 and so on, and rounded to one decimal place is going to give us 5.2 centimeters. So in the next example, we want to find the length of BC. And BC is the base of our triangle, so it's the side opposite angle A in this diagram. And to use the sine rule, we need another pair of angle and side, and we can see that angle C is opposite side AB, and we have values on both. However, we don't know what the value of angle A is, but we know that the angles in a triangle add up to 180, so doing 180 take away the sum of 49 plus 74 is going to give us a value for angle A of 57 degrees. So now we've got all the information we need to use our sine rules. We've got A over sine A equals B over sine B. So we're going to draw a sketch with all the information that we require in our triangle. So we know that angle A is going to be our 57 degrees, and that's opposite side A, which is what we're trying to determine. And we've got 50 is going to be our side B over angle B, which is 49 degrees. And we're going to substitute that into the formula. So our A over sine A and B over sine B is going to give us A over the sine of 57, and that's going to equal 50 over the sine of 49. Now again, we want to isolate A to find the length of BC, and so we're going to multiply both sides by sine of 57 to get rid of the fraction. And so the length of A is going to equal 50 multiplied by sine 57 all over the sine of 49. And if we put that in our calculator, we're going to end up with a value of A of 55.562 and so on. and rounding that to 1 decimal place, we're going to get 55.6, and our units are going to be meters. Now remember that the question asked us for the length of BC, so we need to explicitly state that BC is equal to 55.6 meters. Now in the next example, we have a metal beam which is used to support a bridge, and we want to find the length of the beam. And our diagram gives us some angles and measurements and shows us which is the beam that we're trying to work out the length of. And it's marked B in the diagram. So we need to work out our pairs of sides and angles. So you can see that B is opposite the supplementary angle of the 80 degrees, and 12 is opposite the angle at the top right of our diagram, which we need to work out what these angles are in order to use our sine rule. So we can annotate our sketch with 25 degrees at our lower vertex, and we know that the length that we want is B, and the angle opposite B is supplementary to 80 degrees. That means that they add up to 180 because they're a straight line. So that means that this angle opposite B is going to be 100 degrees. Now you can see in the diagram above that the other pair of side and angle that we've decided to use is marked in green. And that means that we've got our 12 meters, but we need the angle opposite 12 meters. And we can use our properties of a triangle. So 180 take away the sum of 25 plus 100 is going to give us the angle opposite 12 meters as 55 degrees, and we're going to put that into our sketch. So to use our sine rule, we need our pairs of sides, and so we're going to mark them on. So A will be our length B, opposite angle A of 100, and B will be 12 meters, opposite our angle of B, which is 55 degrees. So writing our sine rule, we've got A over the sine of the angle A equals B over the sine of angle B. And substituting in our values, we've got A and angle A are going to be B and 100, and B and angle B are going to be 12 and 55. So we're going to have B over the sine of 100 degrees, and that's going to equal 12 over the sine of 55 degrees. And so B, when we rearrange, is going to be 12 multiplied by the sine of 100 degrees all over the sine of 55 degrees. And when we put that into the calculator, we end up with a value of 14.426. And rounded to 1 decimal place, we get 14.4, and our units are going to be meters for the length of the beam. Now, bearings are used to measure angles from north in a clockwise direction, and they must be written with 3 digits. So if we consider a point where we've got north going straight up, we're measuring it clockwise, and north is at 0, 0, 0. If we go 90 degrees clockwise, we end up at east, which is 0, 9, 0. Then south is 90 degrees further east, so that's going to be 1, 8, 0. And west is going to be 90 degrees further round, giving us a bearing of 270. So in this example, we've got 2 radar stations, Alpha and Beta, that pick up signals from an incoming aircraft. Alpha is 40 kilometers east of Beta and picks up the signals on a bearing of 300 degrees from Alpha, and Beta picks up the signals on a bearing of 070 degrees. So how far is the airplane from Alpha? The first thing we want to do is sketch our question. So we've got 2 radar stations, and they're east of each other, so they're in a straight line, and we've got A, the east of B, at a distance of 40 kilometers. Now the next thing we have to do is we need to mark on our norths at each of our points. So we've got our north at Alpha, and we've got our north at Beta. And this allows us to work out where the plane is going to be in relation to each of those stations. So it says that the aircraft is 300 degrees from Alpha, and so we're going to measure that round in a clockwise direction. West is at 270, and we need to go another 30 degrees round to our 300 degree bearing, and we're going to mark that on as 30 degrees on our sketch. So the plane is somewhere along that red line in our diagram. Now, the next thing we need to do is work out a bearing of 70 degrees or 070 from north for where the plane is going to be picked up from beta. So if we measure round clockwise from north, an angle of 70 degrees, that means that the angle in our sketch down to east is going to be a 20-degree angle. So we can mark that on in our sketch. And the aircraft is where the green and the red lines intersect in our sketch. So the next thing we want to do is take that triangle separately. So we've got 20 degrees at B, we've got 30 degrees at A, and we've got a distance between those points of 40 kilometers. Now, in order to use the sine rule, we need to have the angle P that's opposite the 40 kilometer side. Now we're going to mark on A for alpha, B for beta, and the distance between alpha and the aircraft P is going to be X meters. Now to use the sine rule, we need the side opposite the angle. So our pairs of information are going to be X opposite our sine of 20 degrees, and we need the angle P opposite 40 kilometers. So we need to determine what the angle at P is. So we're going to do 180, take away the sum of 20 plus 30, and that's going to give us an angle at P of 130 degrees. We want to mark that onto our sketch at angle P. Now our sine rule is in terms of A and B. So X is going to be A and B is going to be angle A, and 40 kilometers is going to be B, and our 130 is going to be angle B. So A over sine A equals B over sine B, and we're going to substitute that information in. So we're going to end up with X over the sine of 20 degrees equals 40 over the sine of 130. We're going to multiply both sides by sine of 20 and get X equals 40 sine 20 all over sine 130. And we're going to put that into our calculator and end up with a length of X of 17.859 and so on. And we're going to round that to one decimal place of 17.9 kilometers, which is the distance of the aeroplane from Alpha.